All right, in this session, we want to explore this very important and famous theorem called Bayes' theorem. You might have already heard about it. You might have been very fearful of it, but it is here to stay. It is very important in helping us calculate, predict, and even do AI. A lot of decision analysis, algorithms, and theory are based on the Bayes' theorem as well. So let's just have a foundational understanding of what this theorem is talking about, what inputs do you get, and what you get out of the theorem, right? And then we look at how we can apply them, uh, how to use this theorem and why is it so useful. And then we have an example of how we do that in Excel so that we can see the individual calculations so that we can trace the movements of the numbers. And then we see a couple of application examples. Right? So in applying for Bayes' theorem, first of all, we often talk about the universal set. So here my universal set is split into S1 and S2. And exhaustively, because the whole universal set has to be completely described by S1, S2. And as you can see in the other diagram, we can split it arbitrarily into many uh, subsets, which are all non-overlapping, so mutually exclusive. And there is no leftover little territory where there is no SK around. So every part is described by uh, one particular suffix of S, S1 to SK. These are called S1 to SK because they are often interpreted as states of nature. States of nature. And this, the reason why we call that state of nature is because it is an outcome, an event, or a state of affairs which is not controllable, not decidable by the decision maker or the experimenter at this moment. Okay, for example, a quick state of nature. Will tomorrow be rain or shine? Let's just split the weather into very simple decision. All right, rain or shine. If it's not raining, is shining. If it's not shining, it's raining. Let's just say it's that simple. Then it is S1, S2 because the entire weather is either rain or shine. Or better still is rain or no rain. Okay, so rain or no rain, S1, S2. And all possible weather outcomes for tomorrow is able to be classified under either S1 or S2, isn't it? So the entire universal set of the state of nature of tomorrow's weather is going to be described by S1 rain, S2 no rain. Another example, a lot of examples. If we just limit to S1, S2, yes, no, black, white, then is the coming exam difficult or not difficult? Right? Difficult S1, not difficult S2. Easy or not easy? Coming in this stock, should I invest? Well, no, not really. Will this stock give me profit? That's state of nature. So S1, I will get profit if I invest for 10 days. S2, I will not get profit, meaning I get back just the principal or I even lose money. And that's S2. Now, why is it that should I invest or not invest? Why is that not considered as state of nature? Because I decide whether I invest or not invest. There's no probabilistic nature in it. I just decide. Maybe I'm not decided. Maybe I haven't finalized my decision. Maybe I'm wavering, but that's not to say I, the decision maker, have any probability in it. That's one confusion that's almost always uttered by by people who are not aware. So they will say something like, "Are you going to invest in this stock? Not sure. Maybe 50-50." Right? So if you ask a friend, "Hey, are you going to party or not tonight?" Not sure. 50-50, right? So that's what we say, but that's not really correct as far as probability and statistical theories are concerned, because we are the decision maker. We are not decided. We have no probability in making the decision. But you, as the friend who is looking at you, wouldn't know your decision. So to your friend, yes, whether you come or not come this evening to the party, there is a probabilistic element there, right? So because he or she doesn't know your own decision. Okay, back to states of nature. So states of nature, uncontrollable, unknowable, undecidable outcomes. that the decision maker, the experimenter right now, just has to wait and see. All right, so those are the states of nature. They are all non-overlapping and they cover the entire possible outcomes. There's nothing that's not described by either S1 and S2. Okay. Then we have the I1s and I2s. The I1s and I2s, as you can see, it's kind of a subset of the universal set described by S1 union S2. Right? So they are just another subsets of the universal set. Now, interesting thing in Bayes' theorem is this. The I1 and I2, they are overlapping some parts, all right, of S1 and S2. So here I purposely show in the I1 here, for example, there is a larger portion of S1, and I2 here, there's a larger portion of S2. They may be equal, they may be unequal. There may not be any S1 at all, just purely S2. Okay, that's fine, right? So in the general case, I1 can be overlapping a lot of S1 to SK, and I2 different proportions, and so on and so forth, right? Some may be missing, so S1, S3, S5, S6, 7, 8, 9, 10, so something like that. So it's just a different overlapping subsets of all the SIs forming I1 and I2. So that is the description. How can we think about the I1s and I2s? Now, for simplicity, it can be generalized to pure mathematical abstraction, of course. But for simplicity to think about why we have I1s and I2s, I'm going to just think of I1 and I2 as the events, all right, that there is, first of all, a consultant, all right. There's this third element called consultant. Now, where is this consultant? Consultant, I'm just using it generically. It can be a dice, it can be a person, an expert that you consult with. It can be a computer program, it can be an AI machine, whatever it is. The role of this consultant is this. For many occurrences of the past S1 and S2, this consultant, remember this consultant can be a person, a company, a device, a program, right? This consultant will utter I1 or I2. So what is I1 and I2? I1 and I2, again, for simplicity, let's just finish up this story. I1 means the consultant says S1 will happen. I2 means consultant says S2 will happen. Will happen, will. That means into the future. So the consultant predicts whether S1 will happen, S2 will happen. Okay, so let's just think of the story this way. Now again, I need to stress, in its full mathematical generality, you can assign anything, any subset to I1 and I2. It doesn't have to be consultant or what. But I'm just framing this story so that it's easier to think about it this way, because most of the time, as we'll see in examples and my storytelling, is that the consultant comes in quietly, creeps in, and without knowing it, you are already talking to the consultant, right? So we'll see in a while. So this consultant will predict, I think S1 will happen, so S1 happens. I think S2 will happen, so S2 happens. Okay. Now, I know what you're thinking. Doesn't mean the consultant says S1 will happen, then S1 must happen, right? So think, for example, S1 is Dow economy doing well. Let's say Dow Jones is positive overnight, right? So goes up by a positive. Go is a plus. It closes with a positive gain, right? And S2 is Dow Jones closes with zero or negative gain. It lost losing points. Some major stocks losing money. So of course, Dow Jones closing index is either plus or else zero or negative. Yeah, so that's mutually exclusive and non-overlapping and exhaustive. So that's well defined S1 and S2. So what is the consultant? Now the consultant here can be a trader, can be a computer program, can be Bloomberg terminal, and so on, right? You ask, hey consultant, you type into the program, or you ask the trader, hey trader, do you think tomorrow Dow Jones will go up or down? So the trader will say something, right? Up, because he has to trade, so he has to predict up. Then I buy or sell, And of course, trader can be right or wrong, right? So I predict up, but it went down. I predict up and it went up. So a good trader will be, if I predict up, it goes up many, many times. And sometimes I'm wrong. Hopefully zero, but it can be non-zero. So if we think about it, then of all the past, we kind of roll back into the history, the Dow Jones can go up, up, and then down. And remember, this is history. So it is factual, right? Yeah. So this is history and historical. And so just before each of the arrows, the trader will have to make his or her decision or prediction, right? So 5, 6, 7, 8, 9, 10. Just trying to draw 10 up arrows and then some down arrows. Okay, so you can see that it doesn't have to be consecutively every day the Dow Jones go up, right? Some days it will go down, up, down, up, down. But what we do is we roll back in time and look at past history and say, let's gather 10 such days when we knew in the past that factually Dow Jones went up. And the trader will predict, I think it will go up prior to that day, right? So it was still prediction, but everything is frozen in time now because it's all happened in the past. So trader says up and he was right. Trader says up and he was right. Trader says down, he was wrong, right? Trader says up, right, 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 and let's say all are right and two wrong. So I say up and I say down and it went up and so on. So you can see that we can count 8 up triangles. Predictions are up and they are correct, and 2 predictions of down and they are wrong.